Hello, everyone. Welcome to our Deep Dive podcast, where today we'll be reviewing the fascinating paper, Drivel-ology, Challenging LLMs with Interpreting Nonsense with Depth. Are you ready to explore the world of nonsense with depth too?
Absolutely. I'm excited to discuss Drivelology, a term that's new to many of us. To start, could you explain what Drivelology actually means?
Of course. Drivel-ology is a unique linguistic phenomenon. It refers to utterances that are syntactically coherent but pragmatically paradoxical, emotionally loaded, or rhetorically subversive. In other words, these are statements that look like nonsense on the surface, but actually encode implicit meaning requiring contextual inference, moral reasoning, or emotional interpretation.
That's intriguing. So it's not just random nonsense, but rather nonsense with a hidden message or critique. Can you give an example?
Certainly. One example from the paper is, I deeply admire Che Guevara's anti-capitalist spirit, so I bought all his merchandise. On the surface, it seems absurd, but it's actually a critique of performative activism, highlighting the paradox of admiring anti-capitalism by engaging in capitalist consumerism.
That's clever. It's like a joke, but with more layers. How does Drivelology differ from other forms of complex language, like irony or sarcasm?
Great question. While irony and sarcasm often involve a single cognitive step, like inverting a word's meaning based on context, Drivelology is more complex. It uses multi-layered narratives, pragmatic paradoxes, and ambiguity. It often requires synthesizing cultural knowledge, not just recognizing a contradiction.
So, Drivelology is a real challenge for both humans and machines. Why did the authors focus on this phenomenon in relation to large language models, or LLMs?
The authors wanted to test whether LLMs, which are very good at generating fluent and contextually appropriate text, actually understand deeper, layered meanings. They argue that statistical fluency doesn't necessarily imply cognitive comprehension, and Drivelology is a perfect test case for this.
That makes sense. How did they go about studying this? Did they create a dataset or benchmark?
Yes, they constructed a benchmark dataset called Drivelhub. It contains over 1,200 meticulously curated examples of Drivelology across 6 languages: English, Mandarin, Spanish, French, Japanese, and Korean. Each example was reviewed by experts to ensure it truly embodied Drivelological characteristics.
That's impressive. What kinds of tasks did they design to evaluate LLMs on this dataset?
They designed 4 main tasks. First, Drivelology detection, which is a binary classification task to determine if a text is Drivelology or not. Second, Drivelology tagging, a multi-label classification task to assign one or more categories from their taxonomy to Drivelology samples. Third, implicit narrative writing, where the model must generate a detailed explanation of the underlying meaning. And fourth, narrative selection, a multiple-choice task where the model selects the correct narrative from several options.
That covers a wide range of understanding, from basic recognition to deep reasoning. Can you tell us more about the taxonomy they used for tagging Drivelology?
Absolutely. The taxonomy includes 5 categories: misdirection, paradox, switchbait, inversion, and wordplay. Each category captures a different rhetorical or linguistic technique used in Drivelology.
Could you briefly define each category for our listeners?
Sure, misdirection leads the listener down an expected path before a twist. Paradox involves statements that seem self-contradictory but contain a hidden truth. Switchbait uses phrases with double meanings, often requiring cultural knowledge. Inversion flips a familiar phrase or social script. Wordplay exploits the phonetics or multiple meanings of words.
Thanks for clarifying. How did the authors collect and annotate the data for Drivelhub?
They sourced Drivelology examples from various social media platforms, ensuring diversity in topics and languages. For annotation, they assembled a team of multilingual experts, all with at least a master's degree. The process involved multiple rounds of detection, tagging, narrative writing, and quality checks by a meta-reviewer with linguistics and psychology expertise.
That sounds rigorous. Did they also include non-Drivelology examples for comparison?
Yes, they included both normal sentences and pure nonsense as non-Drivelology samples. This allowed them to test whether models could distinguish between genuine nonsense, straightforward statements, and drivelology.
I see. Let's talk about the experiments. Which LLMs did they evaluate and how did they set up the tests?
They evaluated both proprietary and open-source LLMs, including GPT-4, Claude 3, Qwen 3, Qwen 2.5, Llama 3.1, Llama 3, and DeepSeek v3. All models were tested in a zero-shot setting, meaning they weren't fine-tuned on Drivelology data beforehand. They used 3 distinct prompts for each task and averaged the results.
What metrics did they use to evaluate performance?
For detection and multiple-choice tasks, they used accuracy. For tagging, they used F1 score. For narrative writing, they used BERT score and an LLM as a judge approach, where GPT-4 rated the quality of generated narratives on a 1 to 5 scale.
That's comprehensive. What were the main findings? Did any models stand out?
DeepSeek v3 was the top performer in most metrics, especially in detection and tagging. However, even the best models struggled with the hardest tasks, particularly the hard version of the narrative selection task, which required deeper reasoning and sometimes the option none of the above.
Interesting. Did the size of the model make a difference?
Yes, but the effect was task-dependent. For the Qwen 3 series, larger models performed better on the hardest reasoning tasks, but not always on classification tasks. This suggests that scaling up model size helps with complex reasoning, but not all aspects of Drivelology understanding.
Did the language of the prompt affect model performance?
Yes, it did. English prompts led to better performance on tasks requiring lexical precision and logical reasoning, while Mandarin prompts gave a slight edge in tasks focused on direct content comprehension. This shows that the choice of prompt language can influence evaluation outcomes.
That's a valuable insight for multilingual NLP research. How did the models perform across different languages in the dataset?
DeepSeek v3 showed the most robust cross-lingual performance, but all models struggled more with Korean and Mandarin, especially on the hardest tasks. This highlights the additional challenge of cultural and linguistic diversity in Drivelology.
Let's talk about the reasoning process. Did the models show evidence of true understanding, or were they just pattern matching?
The analysis suggests that even the best models often relied on surface-level cues. For example, in the narrative writing task, models could generate fluent text, but their explanations often missed the deeper, layered meanings. The LLM as a judge scores reflected this gap.
Did the authors compare model reasoning to human reasoning?
Yes, they did. They found that even human annotators sometimes disagreed on the correct interpretation of Drivelology due to its inherent ambiguity and reliance on cultural context. This makes it an even tougher challenge for LLMs.
Can you give another example of a Drivelology statement and how it might be interpreted?
Sure. Take the statement, "I hate 2 kinds of people." The first kind is those who don't finish their. The sentence is left unfinished, which is itself an example of the behavior being criticized. It's both a paradox and a misdirection, depending on your perspective.
That's brilliant. It really shows how Drivelology plays with expectations and meaning. Did the authors discuss the implications of their findings for AI development?
Yes, they argue that the inability of LLMs to interpret Drivelology reveals a deep representational gap in their understanding of complex social and cultural contexts. They suggest that future research should focus not just on scaling models, but on developing training paradigms that target multi-layered reasoning.
Did they mention any limitations of their study?
They did. One limitation is the language imbalance in the dataset, with over a third of samples in Mandarin. Another is the computational constraint, which prevented them from testing even larger or more advanced models. They also focused on understanding rather than generation, though they included some discussion of generative capabilities.
Speaking of generation, how well did LLMs do when asked to generate Drivelology?
Not very well. Even with examples and category definitions, models like GPT-4 struggled to produce outputs that matched the depth and complexity of true Drivelology. Most outputs were either too simple, lacked layered meaning, or failed to align with the intended rhetorical category.
That's a significant challenge. Did the authors propose any future directions for research?
Yes, they suggested 2 main directions. First, using advanced preference optimization techniques like GRPO to fine-tune models on the narrative selection task, which could help models learn subtle semantic distinctions. Second, developing new metrics for evaluating Drivelology generation, focusing on qualities like entertainability, paradoxical depth, originality, and cultural resonance.
That would certainly push the field forward. Did they address ethical considerations in their work?
They did. All data was collected from publicly available sources, with careful filtering to avoid offensive or harmful content. The dataset is released for research purposes only, under a license that prohibits commercial use and redistribution of original content.
That's good to hear. Before we wrap up, can you summarize the key takeaways from this paper?
Absolutely. The paper introduces Drivelology as a new benchmark for testing the deep semantic and pragmatic understanding of LLMs. Despite their fluency, current models struggle to grasp the layered, culturally embedded meanings of Drivelology. The DRIVELHUB dataset and evaluation tasks reveal a significant gap between surface-level coherence and genuine comprehension. Addressing this gap will require new training methods and evaluation metrics that go beyond statistical pattern matching.
That's a comprehensive summary. It's clear that Drivelology presents a unique and important challenge for both AI and human understanding. Any final thoughts?
Just that this work opens up exciting possibilities for future research in NLP, especially in areas that require nuanced social and cultural reasoning. It reminds us that true language understanding is about more than just stringing words together. It's about grasping the deeper, often hidden, meanings that make human communication so rich and complex.
Well said. Thank you for guiding us through this fascinating paper. And thank you to our listeners for joining us on this deep dive into Drivelology and the challenges it poses for large language models.
Thank you, Sue, and thanks to everyone tuning in. We hope you enjoyed this exploration of nonsense with depth. Until next time, keep questioning, keep exploring, and remember, sometimes the deepest truths are hidden in the most unexpected nonsense.
Goodbye, everyone. To summarize, today's review of Drivelology, challenging LLMs with interpreting nonsense with depth, showed that while LLMs excel at generating fluent text, they still struggle to understand the layered, paradoxical, and culturally embedded meanings of Drivelology, highlighting a significant gap between statistical fluency and true cognitive comprehension.